Hello everyone, welcome to TC Club Solutions. In this video, we are going to check whether a given number is prime or not in C++ using trail division method. So what is a prime number? So any number can be called as prime number if it is divisible by 1 and itself. So this method checks if the number has any divisors other than 1 and itself by testing all the numbers from 2 to n minus 1. So this is a kind of basic approach. Let us try to code this. Let us write a CPP code template and we'll be using the namespace std and our entry point to our main function, which will return the status code 0 if the program got executed successfully. Okay, so what we'll do is let us declare a number. We'll get the number from the user and let us give a prompt telling that please enter a number in this way. Okay, so you'll just see out enter a number, where we'll be inputting the number from the user and we'll be storing the value in the variable num. Now, let us have a function. So, a Boolean function which will return true or false if the given number is prime or not. Okay, so let us try to implement that particular functionality. Let us check given number is prime or not. Okay, simply we can have is prime, that's fine. So, this will take this number as an argument to it, by which we can say that we can print out a message telling that the number which you have given is a prime number and add a line break to it. Now, suppose if the condition fails, okay, if the above function returns false, what we have to print is same thing. The given number is not a prime number. Now we have to write the implementation for this Boolean function. As we have discussed, this is a Boolean function which will return Boolean values, that is either true or either false. Now, so the return type is bool and the function name is prime. And what is the argument? It's int number. Okay. Now, the very first condition what we have discussed, see, a prime number is divisible by 1 and itself, and we have no some other conditions like, see, 1 is neither prime nor composite, right? So if any number which is less than 1 or equals to 1 is not a prime number, so it has to return false. So we'll write a condition if the given number is less than or equals to 1. Okay, simply don't do anything, just return false. That's a very first edge case, and we know that 2 is the only prime number. Okay, so the even numbers above 2 are always divisible by 2, right? So the even numbers which are above 2 are not at all prime. So what we can conclude is 2 is the only even prime number. We can check for the condition, one more condition telling that if the number is equals to 2, you can just return false. Okay, you can just return true, as that is the only even prime number. So that's our second edge case, that means second base condition. And what about the next case? If any number, if any even number which is greater than 2 is always not a prime number, that's our one more edge case. So if the number is divisible by 2, that means if the remainder is equals to 0, if it is divisible by 2, that means it is an even number, right? So what we have to do, we have to just return false in that case. So return false. So we are done with our 3 edge cases. We have covered all the 3 corner cases. Now let us think about the main logic. So how are you going to find a number is prime or not? Very simple. You will divide till the number by each and every number starting from 3, and you'll check whether the remainder is 0 or not. If suppose if it is divisible by any number, if it is giving the remainder as 0, then we can conclude that the given number is not a prime number. So what we have to do, we are doing this repeatedly, right? So we have to use loops. So what kind of loop? We know the number of iterations. which is n. So we can use for loop as we know the number of iterations. So I'll start from I is equals to 3 and I'll go till my number and plus plus I'll increment by 1 each and every time. I'll check if the number is divisible by the iteration, that means I. If it is divisible by I, if it is giving the remainder as 0, what I can do is I can simply return false. Okay, and we are done with this condition. So suppose we'll start from 3 and we'll go till the number minus 1. So till the before number, and if suppose if it is divisible by this number, if the remainder is 0, it will just return false. Okay, and after coming out of this loop, that means the given number is not at all divisible by this iteration, that is I value. So what we can do is simply return true. Simply return true. That means we have successfully completed the for loop. So it is not divisible by any number. It has the only divisors as itself and 1. So we can conclude that it is true. Let us try to run this program once. Let us enter 3. So 3 is a prime number, we know that. Let us check for 2. So 2 is a prime number, we know that. And let us check for 7. Of course 7 is a prime number. So this program is working fine. So we have covered the 3 edge cases, the 3 corner cases, and we have started our loop from 3 and we have went till the n minus 1, incrementing by 1, and we have checked each and every time whether it is divisible by the given I value or not. Suppose if it is divisible, we'll return false or else we'll return true. Let us even check for the value 4. So 4 is not a prime number, as we know. We can optimize this solution. Okay, what you can think is, as we know that every even number is not a prime number, you can you can jump some iterations in your loop, right? What you can do is I is equals to I plus 2. We can skip these even numbers. So you can reduce maximum number of iterations using this step. And you do have one more optimization as well. You can find the square root of the given number. You can just go till that particular square root of the number, and later on after that square root of number you don't want to check. Like for example, we have 50. Okay, you can stop the iterations till 25 itself. Okay, so that way you can reduce the maximum number of iterations. We'll discuss in the next session. Okay, so this is a basic prime number, uh, basic C++ program to check whether a given number is prime or not. Okay, and I hope you like this video. Please do subscribe to our channel, and thanks for watching.